MAP4C 7.1, the amount of an annuity. Previously, we've seen simple and compound interest, which is a lump sum deposit that is earning interest, so all of the money all at once. What we're going to learn about now is an annuity. An annuity is a series of equal payments made at regular intervals. So for example, it can be like the mortgage payment that you make at the end of each month. In an ordinary simple annuity, payments are made at the end of each compounding period. This formula will tell you the amount of an ordinary simple annuity if you know the following information. R is the regular payment in dollars. So this is not the principal, because the principal is a lump sum deposit all at once. This is a reoccurring deposit. I is the interest rate per compounding period as a decimal. So make sure that you adjust it based on the number of compounding intervals per year. N is the number of compounding periods. So you can multiply the number of years times the number of compounding periods per year. And the capital I, coming from the second formula, this is the amount of the annuity is equal to Rn, so the regular deposit times the number of times that you have made this deposit. So this is really all of the money that you have actually contributed, plus I, capital I being the interest earned. So your total amount of an annuity is the money that you have submitted plus the interest that's been accumulating over time. And we'll look at an example to try to see how this would be applied. Suppose $450 is deposited at the end of each quarter for 1.5 years in an investment account that earns 10% per year compounded quarterly. Determine the amount of an annuity in 1.5 years, or of the annuity in 1.5 years. So let's look at our given information. We know that the regular deposit is $450. The interest rate, which is 10% per year, is compounded quarterly. And when we see this quarterly, that means that we will need to divide the interest rate as a decimal by 4, because that's the interest that is being calculated at each quarter in the year. And n needs to be adjusted based on our quarterly compounding, which is 4 times per year for 1.5 years, which is equal to 6 years. So we substitute into our formula, our unknown value would be our amount. So here's our equation for the amount of an annuity. We're going to substitute in our values and solve. Now, some advice for how to complete this calculation. It is lengthy. Work from inside of the brackets. I would type 1.025 to the power 6 equals minus 1 equals times 450 equals divided by 0.025. So try this out on your calculator. If you're having trouble getting this value, make sure that you message me. We can troubleshoot. How much interest was earned in 1.5 years? So if we know the amount of the annuity, the regular deposit, and the number of compounding periods, then we can determine the interest earned using the following formula. All that we need to do is rearrange this. The amount is the regular deposit times the number of compounding periods plus the interest earned. To get I by itself, we just subtract Rn from each side. The left and right hand side have been switched as well. So it's equal to, I is equal to A minus Rn. So when we do this calculation, we can see that the sum of the money that we actually put in ourselves is 6 times 450. That's the regular deposit 6 times. So this component, Rn, is representing how much of the money that is the total amount of the annuity came from our own pockets. And this is the amount that, the total amount of the investment at the end that we would be able to withdraw. The difference between those two is due to interest. So the interest is $174.48 in this instance. So this can be very abstract if we're just using formulas. It's helpful to look at the way that the money is invested in a spreadsheet or a table of values. So use a table to model the investment. Starting off with the first quarter. We start off with $0, and at the end of the first quarter, we'll deposit $450. Remember that deposits made at the end of the compounding period is what makes it an ordinary simple annuity, allowing us to be able to use that formula. So our ending balance of the first quarter is $450, which means that our starting balance of the next quarter is $450. Then we start to calculate our interest. Let's just make sure that we've made our adjustment. 10% per year, compounded quarterly. We're using this value, 0.025, because that is the interest rate at the compounding interval. So this 11.25 interest that we have earned in the second quarter is generated by doing this number as a decimal, 0.025, times the starting balance. So this is being earned. Then during this quarter, we'll also make our regular payment, which makes it an annuity. It's a regular payment. It's going to always, at each quarter, have that $450. So then our ending balance at the end of our second quarter is the money that's carried over from the previous quarter, plus our interest earned, and then we make another deposit. So add these three numbers together to get this value. The ending balance of the previous period is the starting balance of the next period. And similarly, notice that our interest seems to be growing drastically, but that's because the amount of money that is invested in this type of annuity is increasing considerably. $450 that is coming out of your own pocket. So the amount that is sitting in the account that is earning interest is significantly increasing each time. So we'll continue to do that pattern. 0.025 times the starting balance gives us our interest that we'll earn, and then we deposit our regular amount at the end of the period. And we continue until we're finished. Now, let's make the connection between the formula and this spreadsheet. Notice that the sum of the deposits, 450 6 times, is equal to 2,700. And if you were to add these values together, the interest earned at each quarter, altogether that works out to the same value as the interest in this question. So hopefully that's made the connection. Try the following problems. Good luck.